Okay, let's start today. So let me share the screen. So today we will discuss the assignment 5 and for the course MA 49. So let's start with the first question. So the question number 1 is saying that P is a partition which is given like this 0, 0.6, 1.2 and like this in the interval 0, 2. You have to find the norm of the partition. Okay. So what is the partition? P is given 0, 0.6, 1.2, 1.5, 1.8, 1.95 and 2 in 0, 2, right? And you have to find the norm of the partition. So what is the norm of the partition? Norm of the partition is, suppose P is a partition, suppose this is x0, we do not, this is by x1, this is by x2, x3, x4, x5 and x6. So the norm is given by the supremum or maximum such that xi minus xi minus 1, where I ranges from I equals to 0 to 5, right? 0 to 6. No, sorry, 1 to, it will be 1 to 6. So I ranges from 1 to 6. So this is the norm of a partition. Okay, so just calculate what will be this. x1 minus x0, it's 0.6. x2 minus x1, it's again 0.6. x3 minus x2, it's 0.3. x4 minus x3, it's 0.3. x5 minus x4, so it is 0.15. And x6 minus x5, what it is 0.05, right? 0.15 again. No, 0.05, right? Yeah, right. It's 0.05. Okay. So then now you have to find the maximum among this. So what will be the maximum or supremum? So norm of P will be, so among them which is the x1 minus x0 and x2 minus x1 is give the 0.6. So norm of it will be 0.6 because this is the maximum among all those, right? So norm of the partition is 0.6. So which option is correct? Option C. Okay. Okay. So we have discussed that this is the assignment 1, means assignment 5, question number 1. So here we have to find the, let me repeat again, here we have to find the norm of the partition. Our partition is given by this. So you have numbering it x0, x1, x2, dot 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 x6. And what is the norm of the partition? It is the supremum of this, xi minus xi minus 1, right? So find the difference between xi and xi minus 1 and look what will be the maximum among them. So if you find the difference, and you can see that 0.6 is the maximum, right? So norm of the partition is 0.6, right? Okay. Is it fine? Okay. So let's move to the question number 2. So you have to find the sum of the squares of the first 10 natural number. So you have to find this. K equals to 1 to n sum k square. What is this? 1 square plus 2 square plus dot 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 plus n square, right? So among them which option will be correct? So if you just sum the first one term, it will be one sum, it will be 1. But if you put n equals to 1, it will be 0. The second option, it's incorrect, right? Because second option, if you put n equals to 1, it will give 0. But n equals to, if you take only one term, this sum will be 1. So the option 2 is false. And if you put again in the option 3 n equals to 1, you will get 3 by 2. It cannot be fraction, right? Because this sum is always a natural number. So this is again false. And look at the first option. What it is saying? If you put n equals to 3, what you will get? N equals to 3, it will get 2, you will get. Yeah, this can be, but you can easily check that this will not be the sum. For 2 terms, what you will get? It will be 3, right? And but if you put n equals to 2, yeah, it will be 3. For 3 times, 1 square plus 2 square plus 3 square, what it is? 9, 4, it's 13, 14. And here put n equals to 2. If you put n equals to 2 there, it will be 2 into 3 by, or 3 into 4 by 2, right? So it's 6. So these two are not equal, right? So again, so option 1 is also incorrect. So only remains the option 3. So we will prove this, that in fact this sum will be this n into n plus 1 into 2n plus 1 by 6. So claim summation k square k equals to 1 to n k square, this will be given by n into n plus 1 into 2n plus 1 by 6. So we will prove this by induction. We will prove this by induction. So suppose this is P of k, P of n denoted by this, by P of n. Then what is P of 1? P of 1, if you note, this side it will give 1, right? Left hand side it will give only 1 square, it is 1. And what is the right hand side? If you put it n equals to 1 into 2 plus 3 by 6, it's again 1, right? So P1 is true, right? So yeah, for n equals to 1, this is true. Now we will assume that suppose n equals to, suppose for n the statement P of n is true. So we will prove that P of n plus 1 will be true. So what is P of n plus 1? P of n plus 1 means we have to prove this. So what is n plus 1 induction process? So if you, for P n plus 1 means k equals to 1 to n plus 1, right? K square means this is 1 square plus 2 square plus dot 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 plus n square plus n plus 1 whole square, right? So you have to find the sum of this, but for up to nth term you know it, right, by the induction step, P of n. So what is this? This is n into n plus 1 into 2n plus 1 by 6, right? So just write it, and this is n plus 1 whole square. Okay, now take the n plus 1 common, n plus 1 by 6, then what you will get? So you will get n into 2n plus 1 means 2n square plus n plus 6n plus 6, right? So just calculate what it will be, n plus 1 by 6 into 2n square plus 7n plus 6, right? So now factorize it. What it will be? If you factorize it, you will get n plus 1 by 6 into, it will be 2n plus 3 into n plus 2. So what you will get? N plus 1 into n plus 2, 2n plus 3 by 6, right? So note that this is the statement for, if you put n equals to 1, you will, what you will get? N plus 1, n plus 2, 2n plus 3 by 6, right? So we are done, right? Assuming n, we have proved n for n plus 1. So P of n plus 1 is true, right? So by induction we are done. We are done, right? Means what we have claimed, that this is true for all n, right? So we are done. So option 4 are correct, right? So sum of squares of n natural numbers, sum of the first n natural squares of the first n natural number is n into n plus 1 into 2n plus 1 by 6. Okay. Now move to the question number 3. What it is saying? A partition is given and a function f equals to 1 plus x square in 0, 1 is given. Now you have to find the difference between UPF and LPF. So what is the function? It is f of x equals to 1 plus x square, right? So how this function looks like? If you draw it, you see 0 and 1. At x equals to 0 it's 1, x equals to 1 it's 2, right? So this kind of it will look like. So it's a increasing, right? So this is an increasing function. It's 1 and here it's 2. So now you have to find the UPF and LPF, and partition is given. What is the partition given? 0, 0.2, 0.4, 0.6, 0.8 and 1. This is the partition. So how to calculate the UPF? UFP. So what is the definition? UFP. So this is upper sum, right? So what is the definition of it is? So suppose we are denoted by x0, x1, x2, x3, x4 and last one x5. So how the upper sum is defined? It is the I equals to 0 to 5 mi. What is the maximum in the interval mi into xi minus xi minus 1, right? Where mi is equals to the maximum of fx for x belongs to xi minus 1 and xi, right? So in this interval, what is the maximum? If it is mi, then we will put it here. Maximum, we will call it mi. And in minimum, this is the minimum of fx in this interval for x belongs to xi minus 1 and xi. So this is the small mi. And so LFP it's defined like summation I equals to 0 to 5 mi into xi minus xi minus 1. So this is the UFP and this is the LFP. So we have to calculate for this partition and for this function UFP and LFP. So just first calculate UFP. So what is the UFP? So it will be, function is 1 plus x square, right? So maximum value in 0 and in the interval 0 and 0.2 maximum is, because it is increasing, right? So 0.2 is the maximum value. So it is the mi will be 1 plus 0.2 whole square, right? So this is the mi and xi minus, what is the length of this interval x0 and x1? It is 0.2, right? 0.2. So this is for the first subinterval. In the next one, from 0.2 to 0.4, again always the maximum, because it is increasing, maximum will be the right side of the points in the subinterval, right? So it will be 1 plus 0.4, right? This is the mi in this interval, means m2 basically, and the length of the interval is again 0.2. Okay, so just write it like this. For the next interval it will be 0.6 whole square into 0.2 plus 1 plus 0.8 whole square into 0.2, and at last it will be 1 plus 1 means it will be 2, right? Because 1 plus 1 it will be 2 into 0.2. So this is the UFP. Now calculate LFP. So what is the minimum in this interval? First x 0 to 0.1, minimum will be the left hand point of the subinterval, right? So it is the 0. So 1 plus 0 square means it's 1 into length of the subinterval is again same 0.2. So it's 1 plus, and for the next subinterval 0.2 to 0.4, it will be the 0.2 is at the point 0.2, it will be minimum. So as function is 1 plus x square, it will be 1 plus 0.2 whole square into 0.2 plus 1 plus 0.4 whole square into 0.2, 1 plus 0.6 whole square into 0.2 plus 1 plus 0.8 into 0.2. Okay, now you have to find the difference between UFP and LFP. So just write it down, UFP minus LFP. So if you write it down this, so from the first one 0.1, then if you write it down 1 will be cancelled, mean you will get 0.2 into 0.2 whole square, right? For the next, what you will get 0.2 into 0.4 square minus 0.2 whole square, right? And for the next you will get again 0.2 into 0.6 whole square minus 0.4 whole square, right? Plus again 0.2 into 0.8 whole square minus 0.6 whole square plus 0.2. Next it will be 0.8 means 1 plus 0.8 whole square, right? So this minus this means 1 minus 0.8 whole square, right? Now if you look at this 0.2 into 0.2 whole square and again 0.2 into 0.2 whole square, but there is negative sign, so these are all cancels, right? This one cancel with this one, this one cancel with this one cancel with this, and this one cancel with this. So what's remaining? It's 0.2, means difference is the half, 1 by 5, right? So we get UFP minus LFP is 1 by 5. So which option is correct? Option number 1. Okay. All other options are false. Okay. So 3 is done. Now let's move to the question number 4. So what is the question number 4? It's saying that if P is a set of all partition of AB and F is a function from AB to R, then for any partition P1 belongs to this script P, UF P1 is the upper bound of the set LFP. So it will be UFP1 is a upper bound because upper bound is not unique, right? It will not be the. So UFP1 is a upper bound of the set this LFP. So we'll prove this. This will be true. Okay. So how to prove this? So you know one result from the class that if for any partition, suppose P and P1 we take two partition, then you know that for any partition P1 and P, LFP is always less than equals to UFP1, right? For any partition this is always true. LFP is always less than equals to UFP1. It's for any two partition P1 in P and P1. This will always hold, right? Okay. So what you have to prove? Now you have to prove that P1 is the upper bound of the set. So this hold for all partition P and P1. Now so as P1 is fixed now, so suppose this we will write it for general partition. Suppose this is for P1 and P2, then you will be understanding. Then you will understand better, right? So suppose we denote it by P1 and it P2. Now what is given? P1 is a fixed partition, it's given, right? So it is also true for any partition, right? So what you will get? So okay. So for any partition P, for any given partition P and P1, we have LFP is less than equals to UFP1, right? Where this P1 is the what is given in the question. P1 belongs to script P. So this is the where P1 is given what is given in the question, and this P is also from the partition for all P, right? Okay. So this is true. This inequality is true for all P in the partition. So now take suprema over all partition P belongs to script P in LHS, and as P1 is fixed, right? So P1 is a fixed partition, as P1 is a fixed partition in script P, right? So what you will get? That supremum over LFP such that this P belongs to all P less than equals to UFP1, right? So we get, by taking the supremum in the left hand side, we get this supremum of LFP over for P belongs to script P is less than equals to UFP1, right? So this is the mean that UFP1 is a upper bound, right, of this set. So which imply UFP1 is an upper bound of this set. Oh, sorry. So this will be the LFP such that P belongs to script, right? So we have proved that UFP1 is an upper bound of this set LFP where P belongs to all partition. So this will be UFP1 is an upper bound of the set this. So this statement is true. Is it fine? Okay, so question number 4 is done. Now move to the question number 5. What it is saying, a function is given f of x equals to 1 by x square, and in the interval, which interval it's given, x belongs to minus 1 comma 1. You have to check whether it's Riemann integrable or not. First of all, it's not defined at the point 0, right? Means there is some problem at the point 0, because it will be infinite, it is undefined. So you can define it to be 0, but then it will not be continuous. Okay, so you have to check whether it is Riemann integrable or not. Means applied there is a problem. Either you can define this to be 0 for x equals to 0. Okay, so but note that there is a necessary condition for Riemann integral. We need the function to be bounded, right? So this is a necessary condition. Necessary condition for Riemann integral, because otherwise you cannot define the UPF, because maximum will not exist. Riemann integral. F should be bounded. Otherwise you cannot define the UPF, right? So note that this function in the neighborhood of 0, it's not bounded, right? It has an infinite discontinuity. So how these functions look like? Minus 1 to 1. So it's 1 by x square, right? At point minus 1 it's 1, and as it approaches near 0 it will become infinity, and again this side it will be look like this. And 0 we have defined to be 0, whatever you will define, but as it has an infinite discontinuity, you cannot make it continuous, and also it's not bounded. In the neighborhood of 0, fx equals to 1 by x square, this function. So this is unbounded. F is unbounded in the neighborhood of 0. So there it's not bounded, right? So you cannot define the UPF. So F is not Riemann integral. So F is not Riemann integral. Okay. So for Riemann integral in minus 1 to 1, right? Domain we need in minus 1 to 1, because if you take the without 0, then it will be integral, right? There it will be bounded. So here the domain matters. In minus 1 to 1, this function 1 by x square is not Riemann integral. So the option, which option is correct? So this is false. Okay. So question number 5 is done. Let's move to the question number 6. What it is saying, f is a Riemann integral function and fa equals to fb equals to 1, and you have to calculate integral a to b f dash t dt. So f is Riemann integral, f is Riemann integral, it's given, and as you have to calculate this, you have to find this a to b, and given what it is given, fa equals to fb equals to 1. You have to calculate in the interval a to b integral of f dash t dt. So as they have defined f dash means f is automatically differentiable, and also because they have defined in terms of this integral a to b f dash t, means f dash t is integrable. Otherwise in general, if f is Riemann integrable, f dash may not be integrable, right? So a priori we don't know. If suppose nothing is given, then we cannot say that or Riemann integral function f dash will be Riemann integral. Okay. But here, as they have defined in terms of this integral a to b f dash t, so you will
சார்
ask,
நீங்கள் மியூட் பண்ணியிருக்கீங்க சார்.
yes, okay, oh, it's muted, I have not, okay, sorry, let me